Hi, everyone. Welcome to our first online lecture recording. I hope you're all doing well. I know this has been a difficult time, and we're all certainly concerned about many issues of health and safety. Yesterday's earthquake was certainly an unwelcome addition to our list of troubles, and I hope everyone's doing okay in the face of that. I will urge you all to take precautions for coronavirus seriously and do social distancing and really try to avoid contact with other people as much as possible. It does seem like things are really just getting started here. Uh, but we're going to push on and see how it goes. So, to remind you of the process, I'm going to record some online material here. And I'm sort of trying out this setup where I have my face here and then sort of lecture slides here and code here, and I'll just sort of work through some stuff like I would in class. And the goal is for you to watch this. You might want to watch it at some people like watching these things at 1.25 speed or 1.5 speed. Make my voice real fast and high, but get through the material a little faster and then slow it down and rerun it where you sort of need to concentrate on certain aspects. And you're welcome to do that kind of stuff. But after watching it, there's gonna be a short Canvas quiz to kind of double check your understanding of the major points, and you should be able to retake that as needed until you can answer the questions. Then during the actual class period, we typically have an optional discussion material. This first one probably today is going to be, since I'm a little late getting this out, is going to be more just sort of a class mechanics kind of thing, and there won't be anything there that won't be repeated on Piazza. So you should also make sure you're set up to get notifications from Piazza. All right, so let's get rolling. My goal is typically not to make this like a full 50 minutes or so, although sometimes we'll see how it all turns out, and if things are sort of in distinct parts, I might even split it into separate files so it's a little easier to find the material. Um, okay, so unfortunately, we're sort of at the point where we're sort of wrapping up one set of material, talking about classes and inheritance. And then soon we're going to be talking about using that in the context of making sort of a formal user interface. Um, but for the context of our Plants vs. Zombies game, I want to just get a few things out there and give you enough information to kind of hopefully get rolling on that second part of the assignment. Now I'm going to sneeze here. Nothing to be concerned about. But okay, so let's review. Let's kind of get our minds back into the game here a little bit and review some stuff about Python inheritance. And then I'm going to do a practical example of adapting one of our old labs into having sort of inheritance as well and see how that goes. So our goal is preparation to finishing the Plants vs. Zombies game. And in that second part, you're going to add multiple types of plants and zombies using inheritance. And then we're going to add some user interface stuff to place plants. And for some reason, my computer is really kicking along here. The fan's kicking on, and hopefully it's not too disturbing on the microphone. I did try getting one of those little earpiece ones, and unfortunately, I didn't think the mic quality was very good, so I have to still try some other things. And when I'm typing, it seems like it's kind of loud. Anyway, I'll work on that and see what I can do. You can already see some of my kind of janky, that light was real bright, so I just have some piece of paper with some tape around it, and we're doing what we can, right? Okay, so down here, I have a class student that inherits from person, and again, the syntax is you just have the superclass inside the parentheses here, and then you need to create the superclass part of your object. So in the init for student, along with just sort of the student specific stuff, we are calling super, which calls the person init, and we're passing in the information there to make what's needed for that. And of course, we have an additional method in the student class here, so we're adding to the person class with some new behavior, and that's fine. And then we are calling here something that exists in the person class, the talk method. It's not code in the student class, it's from the person class. And that's sort of the benefit of inheritance in this context here. Okay, so let's, and then the sort of one sort of special case is when you want to have a new behavior for talk. So not just inherit it, but actually change it. And in that case, we can define inside student a new talk, and we add a new behavior, and then we can actually use the talk from the superclass, from the person class by calling this again through super. Give me the talk that belongs to that super class part of the object. So you can either have it purely custom, in other words, it doesn't have anything to do with the superclass, maybe just say one thing, or you can have some combination where we're both adding some new thing and using the old one as well. So there's a lot of flexibility here, and but part of it's also just realizing all the different things you can do with inheritance and making that work in your context and sort of figuring out what the right path forward is on this. So let's look at an example of turning what was a single class into a multi-level inheritance chain. In other words, having a superclass and subclasses. And we're going to do this with our good old ecological simulation where we had the food and the crabs going around. And we're going to change it to, instead of having just a single crab class, we're going to have a sort of default animal class. And maybe we don't even use that animal class, but we're going to um, then add two specific types, sort of a fast and slow uh, animal, one that sort of jitters around real fast and eats all the food, and but maybe has sort of a limited capacity for storing food, and then one that is slower, but maybe takes longer to kind of run out of food. So let's remind ourselves of what this stuff looks like. This is in PyGame. We had a class food that can draw itself on the screen as a circle, depending, and the bigger the circle, the more more food it's worth, and it grows slowly. And then we had a class crabs, um, and in it took an image and set up a rectangle and set up a health, and then we wanted to draw it on the screen, and we want to be able to move it randomly, so it picked a random number and jittered around. And every time it moved, it also lost a little bit of health. And then there's an eat that basically goes through and sees if it overlaps with any of the food part. And then if it does, it grabs the food, the amount of the food, and adds it to its health, and takes the food out of the list. It gets eaten basically, and it made it so you can only eat one thing. So as soon as this is true, here we ate it, and then we stopped eating food. We didn't want to be able to eat like 10 clumps of food all at once, right? And then we had a spawn, right? Spawn is the reproduction part, and basically if the health is big, it's eating a lot of food, then it sort of subdivides itself and returns either a new crab at that same location, or or nothing. Okay, so those are the two classes, and then just remind yourself of what's going on. I didn't even have a main here. I really should have had a main. We basically initialize PyGame. We set up the images for the crab, and then we bring in we start with 10 crabs to begin with, put it in a crab list. We have a food list, so we start with 50 random foods, and then we go through and we move the crabs. We add more food each turn. We grow the food that's there. We try to go and eat for each crab, we try to eat the food, and then we keep crabs around that have enough health. If they have less than 0, it goes away. And then we basically spawn the crabs. This is going to fill up the new list with both new crabs and none if it doesn't spawn. And so we clean up the new crab list by removing all the nuns out of it. And then we add that new crab list to the existing list of crabs. Okay, so, and then we draw everything. So just keep that in mind. It's already quite a bit of code, and it's going to get a little bit longer. So our goal here now is we're going to add in, I'm going to say a hippo class that's the big, bulky, stores a lot of food, and an insect class that basically reproduces like crazy and doesn't last very long. And we're going to see how those two interact in the environment. All right, so To do that, first I'm just going to get rid of the crabs class and call it animal. And I'm also going to get rid of sort of this speed. That's going to be custom to each of these subclasses. And so we're still going to have an image for an animal and where it is on the screen. And then I'm also going to say, let's let the subclasses decide what the health is for each of these. So I'm not going to set a health for animal here. So animal really is not a fully fledged creature. We're never going to make an animal. We're just going to use it as the basis for defining actual creatures that we want to have in our scene. And then I set its position, which is sort of a dumb method with the rectangle stuff. I still want to draw it, so every kind of animal that we make is still drawable. And here I have a move, and it's complaining because I got rid of that crab speed. I'm going to turn that into whatever the speed is stored in the object we're going to use. Now this is sort of interesting, right? Because we don't actually define a speed for crabs, but when I make this hippo or this insect, they will have a speed. And so when they call move, it can use that, which is kind of interesting, right? That we use the speed from the lower class. And then, let's see, I'm still going to get, again, the health doesn't really exist yet, but the health is going to come from the classes I'm going to define. But everything's going to have a health, and so it's okay to kind of use it up here in the superclass. And eat, I think, should be the same. And I'm going to define the spawn to be specific to each of the subclasses, so I'm going to get rid of that for now. I'm just going to comment that out because I think I'm going to steal it and use it later. All right, so if I tried to run this now, it wouldn't work anymore because the animal class doesn't have sort of everything it needs. But it's basically making a template. It's making a specification for how all the different creatures in our new simulation should work. So let's go ahead and make one of those that inherits from animal. Okay, so I'm going to make a class hippo first that inherits from animal. And of course for hippos, I don't want hippos, this is a single one. And I'm going to define an init. And in the init, it needs to know a lot of information about what it needs to get started. So it has to have an image and it has to have a position. And I'm going to call the animal constructor through super and pass on that image and position. Now I'm going to add in some stuff. So it's going to start off as a big, robust hippo here. Has 200 health. In other words, it's going to last a long time without food. And it's going to have a speed that is very slow. So notice up here, again, we're using self.health. That was not defined for animal, but I'm only going to call eat from a hippo object. And so that health will have been defined when this gets called. Okay, so what else do we need? We don't need draw, we don't need eat, we don't need move. Those are all defined in animal and we inherit them for free. So all I need now is to really define how I spawn. And I'm just going to steal this now. And put it there and uncomment it. All right, so when should a hippo spawn? Well, it should spawn only when its health is very large. And its health should go down by a lot to spawn. And I'm going to make a new hippo at its current location when it spawns. All right, so here we have now, we've changed the behavior of an animal to have this big health and this slow speed. And then we've defined, so that's just sort of changing values inside the instance variables, which some ways you could just kind of change, just pass in new values or something like that if you wanted. But here we have a whole different kind of behavior we're overriding, we're actually making a custom spawn method for it that it says don't split unless you are a big healthy hippo. Okay, so let's do the same kind of thing for the insect. So I'm going to make an insect class. And it gets sort of a low health, but a high speed. And I have to kind of use these same numbers, just kind of make sure the simulation, works out okay and they sort of compete with each other okay. And I'm going to split when I'm healthy, and I'm going to take quite a bit of health off in order to reproduce. Okay, so now the question is, how are we going to use these two classes? Hopefully I remembered everything. So here we're loading crabs images. They don't really exist anymore. Instead, let's load in a custom image for the slow, for the hippo. So I'm going to have, in fact, we're never going to draw an animal. So, oops, what did I just do there? Stop. So I'm going to have a hippo image and then change the hippo image to be this. And I don't want to, the crab doesn't really strike me as a hippo very much. So let's use a different, actually I'm gonna copy all this, and one for the hippo and one for the insect. Okay, insect I'm going to leave as Mr. Krabs, because that's, basically crabs or some kind of sea insect, I think, sort of genetically. And then the hippo I'm going to make into just a nice round golf ball. And take the hippo image and change it. So Mr. Krabs is change the insect image. All right, so here we're loading this and we're smoothing it, and that's sort of all there is to it. Okay, and then down here, this is the key part. So we're done our setup. We've now loading 2 images instead of 1 image. Clean that up a little bit, and I'm just kind of lazy. Well, instead of calling this crab list, let's see. Can I refactor? I'm going to rename that variable from crab list to animal list. It's going to hold both kinds of creatures in it. And then in here, I'm going to first make some hippos. So I've got a hippo, and I call it through the hippo constructor. Then I pass in the hippo image, and then I add to the animal list the hippo. Right? So animal list is going to hold both hippos and insects, and it's okay to hold them both in the same list. And the nice thing is we can go over that list and tell them all to move, because they all have a move method, because they inherit it from animal. And we can tell them all to eat, because they all know how to eat stuff. And so anyway, once we get them in the list, we can kind of just treat them the same and not have to, every time we have a new type of object, add another loop to handle that. We just put them all in the same list and work on them in there. But I'm not done yet, so I made 10 hippos, and so I should make some number of insects as well, and I guess I'll make 10 to keep things sort of fair to start. And so I make an insect from the insect class, and I'm going to use the insect image. See, it gets a little confusing tracking which one you're working with here. I'm going to add the insect to the animal list. So once I do that, notice I'm still calling it crab here. Let's see. I should call that animal and make it, okay, stop, an animal move, because no longer crabs. And food grows, and I'm kind of like, okay, I'm a little tired of changing this, but we'll just go ahead and try to be good about it. There's too many crabs here. I should do a search and replace or something, but um, we will just live with crabs and animals intermingled in meaning here. If I run this, I think it should do something. We'll see. So, Lecture16 in class, that's what's going to run. Okay, so we have, the golf balls are kind of hidden. We have our insects and the golf balls. And the golf balls are kind of blocking out the insects a little bit, but now it looks like the insects are going to escape into the rich food area here. They don't seem to really be acting very differently here. Maybe I have some mistake in my code. Okay, so now I gotta go and look. Let's go look and see what's going on. Like the speeds are wrong or something like that. So, so here this health is big, speed is slow. Here the health is small, the speed is fast. And I make an insect, and I make it a hippo. That's pretty good to me. Tell them all to move. We got crabs. Okay, I'm sure this debugging is just so exciting right here. It looks like it should run. Am I in the wrong? Maybe running the wrong file or something like that. Run this class. I can't, somehow, this is not looking quite right. I'm going to shift to this one and kind of look at it, what's supposed to happen, and remind myself. And I can't tell if they're different or not. Well, one way to do it, sorry, this is all planned out, but let's make the speed like really fast, and then we definitely should be able to tell the difference, right? So sometimes you just gotta like force yourself to like just make sure, okay, so they're different, right? Somehow I was just convincing myself that they were kind of the same there, and I was worried I made some sort of mistake. But, it's always good to, when you have a weird suspicion about your code, you kind of need to do stuff to, well, this is weird that it's some are fast and some are slow. So something is wrong. Okay, so what is wrong? What is wrong? Here it is. I am spawning new hippos instead of insects. Let me put the speed back the way it was. All right, so anytime you have like a vague, just sort of like you're not 100% convinced things are correct, almost always something is wrong, and you really need to slow down and confirm what's going on before you do it. So I was making some insects to begin with, but when I was spawning them, I was spawning hippos out of the insects, which is a little disturbing. Let's run it again. But that's why you need to have a critical eye when you run your own code and just sort of say like, okay, I don't understand what's going on there. Something is not right. So now this is the behavior I was expecting. Notice the fast insects kind of go and swarm and eat up all the food, but then they die out because they are not they don't have a lot of stores. The hippos basically are very slow moving, but they can sort of last through the famine time. Although they're kind of dying out there, they better get themselves into some food area there. And then the insects swarm around them and eat up all the food again and then die out, leaving just enough behind for the hippos to hopefully survive another day down to 2 of them. And again, we can kind of watch this all day, to be honest. The thing I really want to point out, though, is that it was, given a base of an animal, it was pretty easy to define 2 new types here that act differently, and all of a sudden we have a much richer ecological simulation here. You can imagine adding a bunch of different kinds of things, maybe something that doesn't eat the green food dots, but maybe eats the insects instead, right? And then all of a sudden you have predator and prey and stuff like that. Okay, so since we're recording here, I need to actually just kind of move on, I guess. One danger there was that those poor hippos were going to die out, and then maybe we want some way to be like wildlife management, professionals, and somehow do experiments and see what happens if we, add in more hippos to that environment. What would happen? So we want to somehow figure out how to, by hand, add in some stuff. Okay, so we want to add in a button to the scene that lets us click on the button, picture of the hippo, and then click on the scene somewhere, and we're going to put a hippo in the scene. So we want some, godlike control over this simulation. And the question is how to do this. Now, very soon we're going to learn a nice toolkit, PyQt, to be a formal user interface, and it's a nice system, but we're going to just kind of fake it with PyGame for the purposes of this assignment. So basically, what is it that a button should do? Well, we want to be able to see the button, and we want to click on it, and we want to somehow know that that button was clicked. So to fake a button, we're going to draw a rectangle with the image in it somewhere on the screen, and then we're going to check for click events using the PyGame sort of event cube. And if the click is inside the button rectangle, we're going to basically remember that it was clicked. Okay, so we're actually going to encapsulate all this behavior in a class. So we're going to make a button class, and we're going to make button objects and add them to our scene, and then we can just go ahead and use it. So sometimes it's nice to sort of create an object that behaves the way we want it to behave and use it in the rest of our code. Otherwise, you're sprinkling a bunch of sort of variables around these different methods and things, and it sort of gets a little disorganized. But a class is a really nice way to organize this. So I'm going to make a class button, and we're not going to inherit from anything. To make a button, we are going to, I never can get myself to not do that. It needs an image and a position on the screen. It actually looks a lot like an animal at this point, right? It has an image and a position. And we're going to set the image inside the object to this image that's passed in. And we're going to make a rectangle out of that. So self.rectangle equals the image, get the rectangle, and we're going to move that rectangle top left to that set in position, and then that's really all it needs to set it up. And then we're going to define a draw, and draw needs to know what screen it goes on. So I'm going to do the PyGame dot draw, and I'm gonna put a little border around the image, so it kind of looks more like a button, right? So I'm going to draw a rectangle using the rectangle draw command. So at the screen, I'm going to give it a color, red, green, blue, and I'm going to pass in the rectangle that defines the image as the rectangle I want to draw. So, if there's an image on the screen, it has a rectangle, and I'm going to put a border around it using this kind of thing here. And then we're going to actually draw the image of our animal, the hippo or the insect, in order to see what kind of button it is. So I'm just going to draw the self.image on the rectangle location. Okay, and now, right now it's just a way to draw a picture on the screen with a border around it, which isn't very exciting. I want to know if it's been clicked. and I'm going to pass in a position of the mouse cursor when it's clicked, and I'm going to decide whether or not that is inside the rectangle. So all I need to do for that is to call self.rectangle collide point, which is a built-in PyGame thing. It says, is this point, this XY location, inside the rectangle or not? And pass in the click position. And basically, if the click was inside that rectangle, it returns true, and otherwise it returns false. All right, so we've made a button. We're not really using it yet, so let's add some buttons to the screen in our game. So in our setup here, we have we're loading the images and we're loading the insects for the hippos and the stuff, and then we're gonna make the hippos and make the insects, and we make the food, and then here's the game loop. And before the game loop starts, let's add some buttons. So I'm gonna have my insect button is a new button, and it is the insect image, and I'm gonna put it on sort of a location in the upper left of the screen. And then I'm going to make the hippo button. And I'm going to pass in the hippo image. And I'm going to put it a little further over, so its X is going to be bigger and at the same Y location on the screen. And hippo button. Now when I draw, I gotta like track where I am here on this. Let's see, this side. Along with drawing, these aren't real buttons, they're just images. So along with drawing all of the food and the crabs, or the animals, I need to draw the hippo button, hippo button dot draw. You just gotta remember, every time through the game loop, you're basically drawing the stuff that needs to be there. And I'm gonna draw the insect button. And I'm gonna make it draw itself. All right, now these aren't gonna do anything yet, but I wanna again run my code and make sure it does something. I see it. Every time you do something meaningful, you should run your code and make sure something is happening. And I'm crashing. And I need to look at my errors. Draw takes a screen along with it, which I knew but ignored. All right, don't do that. Okay, I'll let it choose for me. Okay, let's run it again. Oh, I moved that really far over. I don't know why that seems sort of ridiculous. Whatever I had in my code. So let's not move it quite so far over. Why did I think that was a good place to put it? Let's see. Screen, what did I really do? Did I misread it? Animal 130, not 300. I just misread it. 130. Okay, now I have two buttons here. Now here's okay. So the last thing we want to do now is I want to be able to click on this button and then click on the screen to place it somewhere. Right now, if I click, I quit the game. I have here, if event type is mouse button down, or mouse button down, then quit the game. Instead, I want to use that event type mouse button down to click on something. And I think this, so let's get rid of this first. We're only going to quit the game if I actually click on the sort of red X on the window. All right, so again, PyGame generates these events. We need to see what kind of event it is, checking the type, and then do something based on that. So if it was a quit, we're going to quit the game. If the event type equals PyGame mouse. I'm going to do mouse button. Oops, not mouse button up. In other words, I've clicked. A click is the releasing of it as well, right? So if it's a mouse button up, there's two things I want to do. I want to see if it's in one of those buttons. And if it is, I want to remember which button it was. Like if I press on the hippo, I want to remember I pressed hippo. And if it's insect, I want to remember I pressed insect, because the next click, I want to make one of those depending on which one it was. So I'm going to check this first. And first I'm going to get the position of the mouse click. PyGame.mouse.get position. And again, I don't really need to make this in a variable. I just think it's a little shorter. It's not much shorter. But I'm just going to get that to start. And I'm going to say if the hippo button was clicked at the clicked position, then I'm going to just remember add animal equals hippo. This is a little awkward, but basically I'm going to store in here, and I'm going to start off by also saying add animal equals, I'll say empty string just to start off. Set it to something like no value, right? And if it wasn't the hippo button, I want to check to see if it was the insect button. So if insect button clicked, insect button, all right, thank you for doubling that down, was clicked, then we're going to add insect. All right, so we click, we check to see where that happened on the screen, and then we just see if that position is inside the rectangle for the hippo button or inside the rectangle for the insect button. And we remember which one was clicked if that's true. So what if we don't click inside a button? Well, it means we basically want to check to see if we're clicking on the screen and we'd already clicked on a button. So if add animal equals hippo, or add animal equals insect, it means we'd already clicked once somewhere, and now we want to click on the screen. And I'm going to see if add animal equals hippo, then actually add the hippo to the animals list. So I'm going to say animal list append a new hippo with the hippo image, and what else does it need? It at the clicked position. Okay, so if we're clicking on a button, remember it. If we're clicking again, and we've already clicked on a button, and then we check to see if it was actually the hippo to add, we add a hippo, and if it's not the hippo, it's going to be the insect, but I'm just going to check that. We're going to append to the animal list a new insect using the insect image. Insect image. Okay, just escape or something. Go away. Okay. Okay, so once we've clicked something, we want to also set it back to forgetting that we have clicked anything. So then we want to go back to being an empty string once we've actually added something. So we click on the button, we remember the hippo or insect, we click somewhere else, we add it, but then we also basically make it so we're not ready to add it again the next time. All right, that's kind of confusing code, I think. You have to kind of think of it because you have to sort of wait, for multiple things to happen, and we're just trying to help the computer remember that we clicked on something on one of the buttons, and then what kind of thing was clicked on, and then we have to store that information so the next time we click that we can add it somewhere. All right, to be honest, I actually kind of changed this logic for my example code, so we're going to see if this actually works or not. I'm a little nervous about it, so we need to test it here. Okay, so we have these things going here. I'm going to click. Hey, I'm not drawing my rectangle. I need to draw my rectangle thicker or something like that, I think. So I have to go back and look and see what I was doing there. So I'm going to click on this, and probably when I was testing, I should print it out saying, hippo clicked. And I click there, and nothing happens. All right, I should not have changed my code at the last minute here. Let me see if I can quickly figure what's going on. If not, I'm not going to make this video drag on forever, and I still post the code that works, and we'll see what's going on. Okay, so if we have a mouse button up, I'm going to print something when something happens, so I can see that that's happening. Mouse clicked. And then if the hippo was clicked, I'm going to print it. So it's always good just to, clicked on hippo. And for the insect, I'm going to print clicked on insect. All right, so let's just find out if these basics are working here, right? So here's this. Mouse clicked on insect. Mouse clicked on hippo. Hey, that looks pretty good so far. So we think that's working. Okay, so, and I'm assuming that this add animal thing at least is doing something here. So if that, oh, you know what? Okay, so as soon as I click here, it's going to be add animal is true. And since add animal is hippo, when I'm clicking on the button, it's going to immediately add in that hippo right away. And it's going to add it in like underneath that button where we can't even see it. So how can I do this? Well, I should have done it with else statements, but I think what I can actually do is just reorder it so that the first thing I check to see if that was set last time, and then if that's not true, I can click the button itself. So I'm not quite sure that's going to work, but let's just kind of quickly, okay, we got these going. Click the insect, and then I add it over there. Click this, and add it over there. Okay, so it just kind of shows sometimes you write code and it seems pretty straightforward, but there's some, in your mind you're thinking those are happening at two different times, but they're really happening just one after the other, and you have to kind of take that into account. Okay, so what have we done here? We've taken a class and turned it into a sort of a superclass that doesn't really get used except for defining how an animal is. We defined two different types of animals based on that, and then we made buttons to allow us to sort of modify this simulation to our own whims. Like I make the poor hippos, hopefully fight back against the insects a little better than they are. All right, so that's it. Kind of quite a bit of code. Look for the posted code. This is really done to aid you in your next assignment. You need to make buttons and add things to the scene, and you need to make subclasses that have different behaviors for the plants and zombies. So let's look at that carefully and enjoy. And I will talk to you later live.